All right, welcome back. So tonight's main lesson is going to be on what is called the alternating series tests, and that can be abbreviated AST in some places, depending on where you're reading. So I call this an alternator, and basically what an alternator is, these are some of the most commonly written ones that they tend to use in AP Calc. Basically, it's causing the sign to alternate back and forth from positive to negative. So, like if you evaluate -1 to the n, -1 to the 1 is a negative number. -1 squared, now we're back to positive, to the third, negative, to the fourth, positive. So these are things that would cause it to ping pong back and forth from positive to negative. So let's just take a second and write these down first. I call these the alternators, or this is the term that will cause something to alternate. And so you want to be familiar with them and recognize that situation. Okay, so once you recognize that we have an alternating term here, this is going to take us to the AST, the alternating series test. And this will test on if something converges. So we are going to run a two-part test. If the limit as n goes to infinity in your series is equal to 0, and now this is just fancy notation for saying the terms decrease. So in other words, for all n, an plus 1 is less than an. So that means the term before it is going to be, if you add 1 to this, that means that this one is less than this one. And then therefore the terms are going to decrease as you go down. So if an plus 1 is less than an. So that would be like saying, if we let n be 7, that's like comparing a sub 8 to a sub 7. A sub 8 is less than a sub 7, and then so on and so on and so on. Okay, so in order to tackle these, you'll notice that we're going to need to locate an a sub n. So in all of these problems, the whole key is to pick up on, oh, we have an alternator. That's just what I call it. So if you see that you have an alternator, remember that I listed these three up above. These are the three most commonly used ones. So if you see one of those, you're going to say, oh, this is just an alternating term. And then we're going to let the actual series be represented by 1 over n. Okay. So you run your test on this leftover term. So the first one, the limit as n goes to infinity for 1 over n. Sounds like 0 to me. Check. And then the second one is going to be, we're going to compare a sub n plus 1. And all you have to do that is just plug in n plus 1 to this one. If I plug in n plus 1 to n, we've got that. And we're going to say, is that less than 1 over n? Well, let's see. All you got to do is just kind of think about that in your head, right? If I plug in 5, just made that number up, that would be what? 1/6 versus 1/5. The bigger number on the bottom means a smaller result. So that is check and check. So then you could say converges by AST, alternating series test. And it maybe would be better to just write the whole thing. So therefore, the summation of n equals 1 to infinity of -1 to the n plus 1, 1 over n, converges by AST. Okay, let's take a look here. And we got a whole bunch to practice with. So let's see what we can come up with for this next one. I see right away, I see an alternator. So see what you can come up with. Does this pass the test? Does it converge? Is there a problem? Take 60 seconds and then we will talk. All right, so this first one is your alternator. And then the first thing we're going to want to do is the limit as n goes to infinity for n over n plus 1. All right, so as we head to infinity in both of these, this plus 1 doesn't mean anything. So this is really n over n. So this limit is heading to 1. And that doesn't work, right? That's not 0. So therefore, this is going to diverge. And just something to take a little note of, not a huge deal. Basically, the reason it is going to diverge is that first thing we learned called the nth term test. So this is kind of more information than we necessarily need. But this test here we learned earlier, and if it was not 0, then it was divergent through the nth term test. So just for your justification, if this ever came up on an AP exam, the reason it diverges isn't because of AST, it would be the nth term test. Okay. Okay, here's two more for you. Let's have you tackle these two, and we will talk in about 5 minutes or so. Okay, so for this first one, the -1 n plus 1 is your alternator. So we want to let a sub n be equal to 1 over 2n plus 2. An is equal to 1 over 2n plus 2. So when we go and try this out, the limit as n approaches infinity for 1 over 2n plus 2, no problem, that does equal 0. And then the second rule, if we plug in an n plus 1 into this would be 2 n plus 1 plus 2, is that less than or equal to the original term? And yes, it would be, because this is going to be a bigger number on the bottom. So this checks and checks. So therefore, the original thing up there converges by the alternating series test. Okay. For the next one after that, we're going to say that your alternator is right there. And then we're going to let an equal n over n plus 5. So when we go to try to do that, the limit as n goes to infinity for n over n plus 5, that's equal to 1, and that doesn't equal to 0. Therefore, by the nth term test, this would diverge. Okay. All right, we've got two more. So go for it, and we'll talk in a few minutes. Okay, so for the first one, hopefully you're starting to pick up on this. We're going to let an be equal to 1 over root n. So if we try our test, the limit as n goes to infinity for this, that is going to be 0. And then the second one, 1 over root n plus 1, that is in fact going to be less than 1 over root n. So this would check out. We're good to go there. Okay, for this last one, that's your alternator. So an is going to be equal to n over n squared. The limit as n goes to infinity for n over n squared, that would be in fact infinity. And when we go and plug these in, you could just kind of go through the same process as before, but this would definitely be decreasing terms. So good to go by AST. Um, let's see what else is in here. So here's a previously asked AP question. If you want to write it down, or if you want to take a picture, or if you want to just take it in, totally up to you. But something like that is a multiple choice question that represents what they could ask from this. If the summation of this, you need to recognize that this is an alternating series when you see the cosine pi n, which of the following is true. So basically, it's just asking you to recite the two rules that we just talked about. What were the two rules? The limit as n goes to infinity for the thing is going to be 0, and the terms are in decreasing order. So that would take us to choice A. Okay. That kind of wraps up alternating series test. Do you guys have any questions on that? Okay. Then I'm going to just run you guys through some questions tonight. See what you come up with. So I've got 10 of these. Wait for the screen to catch up here. Okay, so I'll stay quiet for a couple minutes here on each one. You guys are going to run through. We're going to do 10 questions, get 10 answers, then we'll call it a night. All right, go. So this first one is talking about the comparison test. So remember what we knew about the comparison test. If you had two things and this one was B and this one was A, B could force A to converge and A could force B to diverge. Anybody have an answer on this one? So remember that when we're doing the comparison test, we're looking at 0 to AN to BN is your setup. All right, so for time's sake, this one's going to take us a little while to explain. We'll come back to it. This one was choice C. So this would have been one where this one was able to show that it pushed it up in the air. I want to make sure we get through all 10 of these, though, so I will come back to that one here. We can talk. Okay, next one, length of this. So we don't need an answer. This is a very popular way of writing a BC question. We just want the setup. Something to think about. We need to know the arc length formula in order to answer this. So there was a regular arc length formula that you were given. Okay, so with that in mind, does it make sense to say that we would be at choice D? Okay, that's good. All right, and here is the third one. What are all the values of P for which this series that you see listed over there would converge? So you want to keep in mind here, this is talking about a P series. And what is the rule that we need to know for a P series? When P is greater than one, you get that converge. And when it was 0 to 1, you're getting a decimal essentially. That is when it was going to diverge. So for this to converge, we're trying to figure out what we need to get P to be, what we need for this to be greater than 1. So if you let P be greater than 0, that would guarantee, because if P is 0, that doesn't quite work out. But if P is greater than 0, then that's going to guarantee that you've checked that category there for conversion within a P series. Okay. Any questions on that one? Okay. Number 4. Find the second derivative for the parametric equations listed to the right. So if you're still working, keep going. I'll just start to slowly set this one up here. So if we're going to find the second derivative, we're going to start by finding the first derivative, right? So dy dx is going to be equal to the derivative of the y component over the derivative of the x one. So we're going to take the derivative of what we see for y. So it's going to be chain rule here, e to the stuff. So e to the 3t plus 6, and then plus this plus 6 is going to disappear, right? And then times the derivative of my stuff. So that's going to be e. We should just be able to just throw a 3 in front of that, right? Let me see here. Yeah. So that's just going to be times 3. So this is e to the stuff times the derivative of the stuff. And on the x one, it's going to be e to the stuff times the derivative of the stuff. So if we clean that up, that's 3e to the 3t plus 6 over 30e to the 6t. And then I would simplify that again. So we would say that would be what? Just 10 on the bottom. So 10 e to the 6t, and then e to the 3t plus 6. Okay, so now you have some options here in terms of what you could do. I don't think anything's wrong with that. But if you wanted to try to clean this up and make this a little easier, we could flip this e to the 6t upstairs. If we flip that e to the 6t upstairs, that would be e to the 3t plus 6, e to the negative 6t over 10. And then what do you do when you have these side by side? You add them up. So that would really be e to the negative 3t plus 6 over 10. So I'm going to go ahead. I think that's a cleaner version. You should still get the same answer if you did it this way. So I'm going to go ahead and call that my first derivative. And then to do a second derivative, what should we be doing there? We should just take the derivative of the top part, the dy dx part, and then keep the dx dt part. So let's see, do I like doing that better that way or not? Let me see. Maybe not. I don't know. Which way did you guys come up with the same answer doing it the other way? I'm trying to decide if this is a better way or not. So might maybe just go ahead and keep what we had, which is right here. And then define the, I don't want to get it overcomplicated. I'm going to scratch that step. All right. And then to find the next one, we're going to just do what? We're going to take the derivative to find the second derivative. We're going to just do the derivative of the top part. So that's d dt of what we had. And then we're just going to keep the bottom. Okay, so if we just take the derivative of what's on the top, that's going to be e to the stuff times the derivative of the stuff, and then we're going to just keep what we had on the bottom, e to the 10e to the 6t. Okay, so that would be 3e to the 3t plus 6 over 10e to the 6t. And now we got to start looking for answers and stuff that would match up. This would need to flip upstairs. And then if we flip this upstairs, that's going to be 3e to the 3t plus 6, e to the negative 6t over 10. And then that's going to be 3e to the negative 3t plus 6 over 10. You guys coming up with choice A? Yeah.
Yeah, but why would it be negative? Because it says negative 3e.
Yeah, yeah. So right here, these two things, when you right where my pen's at, when you're multiplying exponents, in other words, like if I
Yeah.
say a to the b times a to the c, that's a to the b plus c. So
Yeah,
if
I
you
know,
add,
but the coefficient negative, it becomes negative on a. It's negative 3.
oh,
Why is that?
did I miss a sign? I see what you're saying. I didn't see the negative up front. Bum, bum, bum.
Yeah, I don't know why it switches signs. I think
Well,
it would switch signs if you simplify it on the first derivative.
Taylor, you said you got choice A. Did you have a negative sign in there?
I don't, but I also may have made a mistake.
It could be a typo as well, guys. These are hand copied. There's a chance I could have copied this and it didn't.
Well,
I
no,
mean,
because if you were to simplify it in the first one, you would get like the e to the negative 3. And then
yep.
once you do that derivative, the constant would
Then
become
you get
negative.
then you do get your negative.
Yeah.
But if you keep
If
it
you
the way you
don't,
don't, you should be an
yeah.
equivalent answer though, right? I mean, it's not like we're changing the problem. I don't see why that would give you a different. Because if you don't change it, then you get e to the stuff times that over that.
Yeah.
All right, just out of curiosity, let's go change it real quick. Let me go up here. If we did do that, it would have been what? E to the negative 3t plus 6 over 10, right? So then if you take the derivative of the top up there, that's e to the stuff times the derivative of the stuff over 10. And then that checks right out. Huh,
Yeah.
interesting. Um, I'm gonna have to think on that on why, because those are equivalent statements, no? I'm gonna have to think on why one of those gives us. I'll get back to you. I got to think on it. I don't want to keep you here all night. The big takeaway of this, though, is that when you see this, um, this is our first derivative. And when you want to take the second derivative, we only do stuff to the top and you keep the stuff on the bottom. That is our big takeaway from that problem. Okay. All right. Next one. Given the parametric equations, what is dy dx at 1? Whoa, timeout. My brain was, I just figured out what was wrong here. Sorry to interrupt you. Hold on. We got a big problem. Usually I wouldn't go back here. We, all of us, we did this wrong. Hold on. I just answered all the questions you had. I need a piece of paper. Fix that. All right, hold on. The formula for this is dy dx is equal to dy dt over dx dt. Okay. And then the second derivative, d2y dx squared, is equal to d dt dy dx over dx dt. Reread what this says. We did this wrong. Hold on. When you do this, all right, the first derivative, no problem, right? We're going to take the derivative of the top, we're going to take the derivative of the bottom. We got it. The second derivative says d dt, the entire thing that we just did. You're taking the derivative of the entire, that's going to be a quotient rule. You follow what I'm saying? dy dx, when you go through this, let's go back to where we were. Dy dx, what did we come up with for an answer? We said it was e to the 3t plus 6 over 10e to the 6t, right? That is dy dx. The second derivative says to take the derivative of dy dx and put that over dx dt. Dx dt is your 10e to the 6t. But up top, they're saying to take the derivative of dy dx. This is dy dx. Does you get what I'm saying? So this would be a quotient rule on what you have up here. So if you quotient rule this up here, this would be bottom derive the top minus the top derive the bottom over the bottom squared. And then you would need to turn that into a four-story fraction, and you would need to go through and do a whole bunch of simplifying to come up with an answer. Does that check out with what that formula is saying? We were breezing through that, myself included. ddt of dy dx means this whole thing that's up here is what you're taking the derivative of, okay? All right, carry on. Sorry, that's where the mistake was in that question, though. Okay, for number 5, find the dy dx at t is equal to 1. Did you come up with -1/8? Okay, yeah, -1/8 is your answer there. All right, number 6. Let's see what we got here. For which value of k does both this and this converge? For which value of k does both this one and this one converge? So as a hint, we want to think about what we're talking about. This looks pretty geometric-like to me. And this over here looks a whole lot like that alternating series thing we just talked about. So we kind of want to piece together what you would need for each of those to work. Let me ask you this, can we at least rule some values out from this one? If I want this to converge, this ratio needs to be a fraction between 0 and 1. So that should get rid of 2 and 3 right off the bat. So we should be able to rule out A and B. Because if it's 3/4 or 3/5 to the n, that one would converge. So I know right away A and B are out the door. See if you can go from there now. So in order for this to become alternating, what do we need? What number do you need up here? If I put a 5 in, -2 to the n isn't something that alternates. In order to create an alternator, we need this to be a -1 up here, which is why 4 would be the winner. And then you can test it out. The limit as n goes to infinity for 1 over root n plus 3, that's equal to 0. And then whenever you go with the second rule, 1 over n plus 1 plus 3, that's less than 1 over root n plus 3. But the whole key to this is in order to make an alternator out of this, you got to put a 4 up there.
Are there only 3 alternators?
Yeah,
Or can
pretty
you
much.
have like
It usually involves the number -1
Mhm.
or like cosine, basically. Cosine pi n is the other big one that they use.
Okay.
Okay, let's find the solution to the differential equation that you see with point, what you see there, given. So you'd want to split your terms and see what you can come up with. All right, so you should have split these up, and that should then, when you integrate, give us natural log absolute value of y is equal to, if we integrate secant tangent, that should give us secant x plus c. And then they've given us the point pi over 3 is equal to 5e squared. So this is going to be natural log of 5e squared is equal to secant of pi over 3 plus c. So then our next question should be, what's going on at secant at pi over 3? Pi over 3 is 60 degrees. At 60 degrees, the cosine value is a half. So secant of pi over 3, we're going to go ahead and scratch that out and call that 2. So then this would be natural log of 5e squared minus 2 is equal to c. And then from there, we would want to go back and plug that in. So that would be natural log of y is equal to secant x plus natural log of 5e squared minus 2. And we're trying to solve this for y. So we would want to raise both sides, essentially. This is going to be log base e. So this would become e raised to the stuff on the right side is equal to y. And then we need to just figure out a way to simplify this a little bit. And then all you got to do is just give each one of these its own e, and then see what we come up with. So this is going to be e to the secant x. Lock that one in. And then we know that e to the natural log of some stuff is the stuff. So that's just 5e squared. And then the last thing I see is e to the negative 2. That would be 1 over e squared. So then that e and that would cancel. And that leaves us, I'm seeing 5e to the secant x. I'm coming up with choice C. Are we on board with that? Okay.
Is there a simple way to derive the secant tangent? I just ended up using u substitution.
Oh,
Right, so there's
yeah, basically. So, where'd my scratch paper go? That's one that you can memorize. So whenever we're going back to basic integration, like day one integration, I would have taught it to you guys as the integral of f prime is equal to f. So if you, in the most basic sense, the answer to an integration problem, if you take its derivative, it should be the thing tucked inside. And then, so like, that's just like saying, if I want to take the integral of cosine, we should be able to quickly say, oh, it's sine, because I know if I take the derivative of sine, I get cosine. So the best bet is, and for the AP exam as well, you would want to have all 6 trig derivatives memorized. So when you get to that right column, if you have the regular one is secant, the derivative of secant is secant tangent. So then if you have secant tangents, and so they're real famous for that. Like they'll give you something that you can have memorized inside the integral. So then you can just run through that process and say that that's equal to secant. Okay. Good. Okay, the other 2 questions that were at the end of this, they were no big deal. So we'll wrap it up there. I don't want to keep you guys here forever. That's been a good hour. So that was alternating series test and some good BC review. So we're down to 2 packets left in terms of what I have left to present to you guys, and then we'll do some more review and stuff. Class will be tomorrow night at 8:30. Make sure you spend a good amount of time. Obviously, these sessions are good. I'm showing you the material. That link I posted on Canvas to that YouTube page with the College Board stuff, there's probably 10 hours of videos, and that's as good as it's going to get. Those are the people that rate your test. So anytime, like this Thursday, I'm not going to be around. I said in that last week's update. So this Thursday, definitely watch some videos. Anytime you guys want to sit down and study, I think watching their videos on that YouTube link is your best bet for studying. So make sure you carve out some time to do that. Okay. Other than that, have a good day tomorrow, and I will see you guys tomorrow night at 8:30.
Thank you.